In this lesson, we'll explain how to use the Matlab SDK. First, we open the XINGYING software. Then click on Data Broadcast. Next, select the network card's address. Here, we choose 10.11.198, then click Enable SDK. Next, click on Edit Mode to load data. You can also play the data using the camera in live mode. Next, click on Matlab. Here, we load the Matlab SDK demo working directory. Double-click on the file matlabsdsample.m. This opens the Matlab SDK code. We then set the network port. This port must match our network card's address in XINGYING. If it doesn't match, communication will fail. Let's run it. In the command window, you'll see the motion capture data information. Now, let's go through the Matlab SDK code blocks. The first block sets up the network session. The next block handles session information. Following that is the data session. First, we look at the network information block. Here, we set the network port to ensure communication between XINGYING and Matlab. We establish Matlab within XINGYING, initialize the network communication. Next, we handle the description information. We retrieve the description information, obtain the count of description entries. Here, you get the description of marker sets, rigid bodies, and force plates. Next, we discuss data information. Here, data for each frame is retrieved. We obtain the timestamp for each frame. We retrieve marker set data. We find out how many marker sets there are and the count of marker points each contains. Here we obtain the marker set ID and its XYZ coordinates. For rigid bodies, we retrieve. Here, we also find out the number of marker points in each rigid body, the rigid body IDs, the X, Y, and Z coordinates, and the QX, QZ quaternion values. Here, we can identify the number of marker points contained within the rigid bodies, as well as the ID of these marker points, including their X, Y, and Z coordinates. Next, we access information related to the skeletons. We can determine the number of skeletons here. Here we identify the ID of the skeletons, including the number of rigid bodies they encompass. We can also retrieve the ID of each rigid body, along with its corresponding XYZ positional data and the QX, QY, QZ quaternion values. It's possible to ascertain the number of rigid bodies. Each skeleton includes the number of markers within these rigid bodies, the ID of each marker, including their X, Y, and Z coordinates. We can obtain data on unnamed marker points and their X, Y, and Z coordinates. Moving on, we gather the simulation data. Here, we can check the count of simulation data entries and their details. We determine the number of named marker points and their X, Y, and Z coordinates. Once the data collection is complete, we terminate the connection with XINGYING from Matlab.